Hello and welcome to this video on multiplying and dividing radicals. So we're going to look at some questions where we're multiplying, we're going to do some questions where we're dividing, and we're also going to do some questions where we rationalize the denominator. And you're going to see what that is when we get to that. So our steps for multiplication, all you do is you multiply the coefficients. So you're going to multiply the numbers that are in front, so the -2 and 3. That'll be step 1. And then step 2, and you can kind of do it at the same time, but the second one there is you're going to multiply the radicands. So whatever's inside here, you're going to multiply those things together. And then at the very end, what you need to do is you need to check and see if you can simplify it any further. So looking at our examples, it says multiply and simplify the following. So number 1, like we had said up top, we're going to multiply the coefficients. So -2 times 3, so those go together. And then inside my radical, I'm going to multiply the radicands. So that was a 2x times, the other one had a 6 inside. Okay, and then we just simplify and see what we get. So the coefficients, -2 times 3, that's -6. And then inside the radical, 2x times 6, that is 12x. And now the last step, we got to simplify. So this 12, I'm going to break that 12 down because this is a square root, right? There's a hidden 2 there. I'm going to break that down into a 4 and a 3. And then the square root of 4 is a 2. So a 2 is going to be able to be brought out, and we got to multiply by the coefficient in front. So 2 times -6, that is -12. And then this 3 and this x, those are stuck inside the square root. So we got the square root of 3x. Looking at number 2 here now, so we got some brackets where there's 2 terms inside. So what we need to do is we need to distribute that in just like we normally would if we didn't have any radicals. So I'm going to have the -2 cube root 9 times the first one, and then also times the second one. So let's write that out. So -2 cube root 9 times by 4 cube root 2. And then we also have -2 cube root 9 times -3 cube root 3. So now we can multiply those. So again, we multiply coefficient with coefficient. So -2 times 4, that's -8. And then cube root 9 times cube root 2, multiply the radicands. So that's 18. And then this is a cube root. And then with our second one, we got a minus and a minus. So those two negatives, those are going to cancel out. We're going to get something positive. And then 2 times 3 is 6. And then multiplying our cube roots, 9 times 3 gives us 27. Okay, and then last step, see if we can simplify this. So 18, you want to try to break that down into some perfect cubes, but you can't break down 18 into any perfect cubes. For the 27 here, though, the cube root of 27, that is actually just equal to a 3. So I'm just going to write out the first one. It was -8 times the cube root of 18. And then with the second one, it was plus, and then we had 6 times that 3 there. So that's going to give us 18. So we're done with that one. We can look at number 3 here now. So this one has now 2 things in each set of brackets. So for this, we're going to have to do our foiling. So we're going to have these 2 multiplications here first. So let's do that first one. So 4 root 2 times root 7. We'll write that out. 4 root 2 times root 7. Then we're going to have this one. 4 root 2 times a -5 root 14. And then we're going to have these other 2 multiplications, so 3 times the root 7. And then also 3 times -5 root 14. So now that we have that, we can do our multiplications. So with this one, we're going to have 4 times, there's a hidden 1 there in front, so that's just equal to 4. And then 2 times 7, that's equal to 14. Then with the next one, we got a positive times a negative, so that's going to equal negative. And then the 4 times the 5, that is equal to 20. And then 2 times 14, that is equal to 28. So that's inside the radical. And then looking at the next one, 3 times root 7, that's just equal to 3 root 7. And then the last one, a positive 3 times negative 5, that's just equal to a negative 15, and then don't forget to write the square root 14. So now that we have that, I can see I have this root 14 and this root 14, so I'm going to put those together. And we learned how to add and subtract in our last video, so we just take the coefficients and put those together. So 4 minus that 15 at the end there, 4 minus 15 is negative 11, root 14. And then this 28, I can simplify that. I'm going to break that down into a 4 times a 7, and then the square root of a 4 is a 2. So I'm going to have 2 times 20, so I'm going to have negative 40 root, and then the 7 is left over inside. So negative 40 root 7, and then I still had this one, so I'm going to go plus 3 root 7. And then in my last step, I can put those two root 7s together. So I'm just going to rewrite the first term we had there, the root 14 one. And then putting these two together, just add the coefficients. So negative 40 plus 3, that is equal to negative 37. And then don't forget the root 7. So last one now here, number 4. So we're going to have to, again, kind of like number 2, we got to distribute this into each of those terms inside the bracket. So this one I'm going to do a little quicker. So I'm going to multiply coefficient times coefficient. That's negative 8. Radicand times radicand. That is going to be 22 c to the power of 4. And then don't forget your square root. Then I had this second one here. So I'm going to have negative 2 times negative 3. That's going to be positive 6. And then inside the square root, 11c times 3 is 33c. And then in our last step, we're going to have to try to simplify. So this 22, there's no perfect squares inside of that, so I can't simplify that. C to the power of 4, though, 4 is divisible by what the index here is, which is a hidden 2. So I can simplify that. 4 divided by 2 is 2, so I got a c squared. And then this 22 is still stuck inside the radical. With the second one, 33 and a c, neither of those have any perfect squares in them, so I can't simplify that. So it's just going to stay the exact same. So now that we're done our multiplying examples, we're next going to look at dividing, and the steps for those are pretty much the exact same. It's just you change the word from multiplying now to divide. So in the first one there, what I'm going to do is I'm going to break it up so that I put my coefficients with my other coefficients. So 28 and 7, I put those together. And then there's multiplication in between these two here. So I'm going to have multiplication in between here as well. And then I'm going to put the 15 and the 3 together. So those are both in the square root. And then I'm going to simplify what I have. So 28 divided by 7 is 4. And then inside my square root, 15 divided by 3, that is equal to 5. And then again, always just make sure that you check and see whether you can simplify. In this case, we can't simplify that. So looking at number 2 here now, I'm going to put my coefficients together. So 24 and 8, put those together. And then these are both cube roots, so I can put these two together. So I'm going to draw a big cube root. And then inside, I got 21x squared divided by 3x. And I'm just going to extend this line. Make sure your radical line always goes over top of everything that was inside. So simplifying this, 24 over 8, that's just going to give me 3. And then inside my cube root, 21 divided by 3 is 7. And then x squared divided by x is just an x. So that's my final answer. Oftentimes with dividing radicals, whatever you get in the end, there won't be really any simplifying that you can do once you actually do the division. With multiplication, a lot of the time after you multiply, you can simplify it down afterwards. So looking at this next one, again, we want to put all of our coefficients together. So I'm going to put the 25 and the 5 together, and then I'm going to put my x's together and my y's together. So x cubed with that x, and then I had y squared. That's going to go with that y that was on the bottom right there. So that's all of my coefficients, and then I'm going to have my square root, and inside was an xy cubed being divided by an xy. So to simplify this, 25 divided by 5 is just 5. The x cubed divided by x, that is x squared. Remember our exponent rules. You take the exponents, and when you're dividing, you subtract them. So it's a 3 subtract a 1. With the next one, we are going to have y, and then you have 2 subtract the hidden 1 that's there. So that's going to give me a 1, and I don't have to write the 1, so I'm just going to put y just like that. And then inside my square root, the x's are going to cancel. So I don't have any x's, and then the y's, I'm going to have 3 subtract 1, so I'm going to have a y squared. And now with this one, I actually can do some simplifying in the last step. The y squared here in a square root, y squared is a square, so when I take the square root, I just get out a y. And then I'm going to have to multiply that down in front with this y, and so I get 5x squared y squared. So that was our last one for dividing. Moving to the last thing we're going to look at here, which is called rationalizing. So in math, there's kind of the rule where you can't have a radical in the denominator. So it says here, a radical in simplest form cannot have a radical in the denominator. So in the bottom of a fraction, there can't be a radical. So rationalizing eliminates this condition. So it'll get rid of the radical in the denominator. If the radical is a single radical, which just means there's just kind of one thing there, we're going to rationalize by multiplying both the numerator and the denominator by a single radical. So we're going to multiply the bottom and the top by a single radical. If the denominator is 2 terms, so that is going to be one like number 3 here. There's 1, 2 terms. For that, what we're going to have to do is we have to multiply both the numerator and denominator, again, has to be both, by the conjugate of the 2 terms. So that word conjugate, that's a new term. The conjugate is right here, or an example of a conjugate. If you had a plus b, the conjugate of that is a minus b. What you do is you just change the sign to the opposite. So if it was a plus, it changes to a minus, and if it was a minus, it would change to a plus. And then a good thing to note, it says the product is a squared minus b squared. So you can do all of this foiling, all your multiplications, but you're going to get this, a squared minus b squared. So to do it a little quicker, you can just square the first term and then go minus, square the second term. Okay, so let's look at our first one here, number 1. So what we want to do, we got a radical here in the denominator. So to get rid of that, we have to multiply by that radical. We got to multiply by root 2, but we have to do it in the numerator as well. So multiply by root 2. So after we do that, in the denominator, remember we multiply radicand times radicand, but what's going to happen is these roots here, they're just going to cancel, and you're just going to get out a 2. So we had a 5, and then it's going to be times by, and then root 2 times root 2 is 2. So anytime you have root of something, I could put in, say, an a, and you multiply the root of whatever that number was, you're going to get out that number. So if you had the square root of, say, 10,000, and you times by the square root of 10,000, you're going to get out 10,000. Okay, so it's just a quick way to do multiplication like that. So this denominator here is now rationalized. There's no radical. In the numerator, we just got to multiply the two roots here. So I'm going to have 6, and then multiplying 5n times 2, that's going to give me 10n. And then let's simplify this. In the top, I'm just going to keep it as what it currently is. And then in the bottom, 5 times 2 is equal to 10. And then I can do some canceling. I can divide both of these by 2. So I'm going to get a 3 and a 5. And so we get 3 root 10n divided by 5. And now I'm just going to make a note of something. You can't divide this into here, right? Our dividing rules, you had to have a radical and a radical in order to put these together. So you can't go 10 divided by 5 and get a 2 up here. Okay, so this is our final answer. Number 2 here now, we got -7 over 2 times the cube root of np. So to get rid of this cube root, we're going to have to times by something. So I'm going to times by the cube root of 9p. But if you ever have cube roots, because you have a 3 there, you need to multiply so that you have 1, 2, 3 of them. So I need to multiply by another one of these. So another cube root 9p. Okay, and I'm going to do the same in the numerator. So simplifying the denominator, we had a 2 down there, and then a cube root 9p times a cube root 9p times a cube root 9p is just equal to 9p. In the numerator, we had the -7, and then cube root 9p times cube root 9p is going to equal the cube root of 9 times 9 is 81, and then p times p is p squared. So we've rationalized the denominator. There's no more radical down here. So I'm just going to simplify this a bit. So in the denominator, 2 times 9 is going to give me 18, and then the p. In the numerator here, we had 81, and 81 has a cube root inside of it. I can break that down into 27 times 3, and then the cube root of 27 is a 3. So a 3 can come out and get multiplied by that -7 in front. And so we get -21, and then inside of our cube root, there is a 3 and a p squared still inside of there. So 3 and a p squared. And then one final thing we can do, now we have this 18 and this 21. Both of those are divisible by a 3. So I'll divide this by 3, I'll get 6. Divide this by 3, I'll get a 7. And so my final answer is -7 times the cube root of 3p squared divided by 6p. So the last one here now, number 3, we're going to work on that. And this one's got 2 things in the denominator. So this one I'm going to have to multiply by the conjugate. Okay, and remember the conjugate was just the exact same thing, but we changed the sign. So this is going to change into 2 root 3 plus a root 5. Okay, so I multiply in the denominator, and I have to do that in the numerator. So when I do that multiplication, let's do the numerator first. I'm going to have a 2 root 2 times a 2 root 3. So 2 times 2 is 4. And then the radicands inside, 2 times 3 is equal to 6. Okay, and then plus 2 root 2 times a root 5. So there's only a 2 out front. And then inside the radical, 2 times 5 is a 10. So that's for our numerator. In the denominator, remember we had said if you multiply by the conjugate, you're just going to take the two numbers and square them, and there is a minus in the middle. So what I get out of this, I'm going to have 2 root 3 squared minus, and then the second one was a root 5, and we square that. Okay, so in the numerator, we can't simplify anything there. We'll just keep it as 4 root 6 plus 2 root 10. And in the denominator, I'm going to square those terms. So we got to square the 2 and square the square root 3. So 2 squared is 4, and square root 3 is just 3. So I'm going to have 4 times 3. With the second one, square root 5 squared, that just equals 5. And then to finish this off, I can just simplify in the denominator there. So 4 times 3, that is 12. And then I'm going to be able to go 12 subtract 5. So in the denominator, 12 subtract 5, that's going to give us 7. And the numerator is still the same, 4 root 6 plus 2 root 10. There's nothing you can simplify there. And then just one final note with this, because oftentimes you might get a number here where maybe you can divide it by this number here. Like maybe you had 14 here, and 14 you could divide by 7. Okay, the only time you can divide that into this is if you can do it with both of these. Okay, so you can't just pick one and divide just one term. You have to divide both terms. So that's it for examples. I'm just going to write out our textbook questions now here at the bottom. And for questions 1 to 11, you're only going to do parts A and C.